Alright, so this is the 3D printed spool that I had made at the university. And it was made, this is Laser Saber's STL file. And I've just been playing with it. It looks dirty and kind of messy because I just took the soldering iron and I just heat it up and I just kind of clean up some of the rough plastic edges and stuff. There was a lot of mess on the inside of the spool, so I just melted that down. Yeah, and then the inside was too big, so I just melted it down a bit. With a soldering iron, that's your best option for cleaning up 3D printed parts that are not the right size, too big, or whatever. If you use a sander, I mean, you could. It works, it's just not as good because 3D printed parts are very porous, and I just found that I prefer making them denser by melting them in rather than sanding off material and making them weaker. So that's what I do. When you heat it up, it gets pretty flimsy as well and bends and contorts a bit, so you gotta watch for that. But yeah, and then I'll just wrap the wire and then it just slides in on both ends and just go right inside there, and that's it. I'll wind this and then I'll show you what it's like. It's been a while, but I have to rewind the secondary, so I'm gonna show you what's going on. I just took out the bolt here, so remove this part and add some super glue. An awkward angle, but okay. Alright, so we separate the two. I'm trying to be careful because I don't want to damage anything. Since I'm having trouble trying to... Oh, are you kidding me? Look at that. See, this is a huge problem with these pot cores. I didn't even put any pressure on it and it's already snapped. Look at that. Well, that sucks. So we're going to be rewinding the coil, so we're going to just remove it from the whole circuit board. I bought 3 sets of these, and one is already broke, so that means that I can obviously use the surviving pot core from the other one I broke, and it's not a big deal. No, not an actual loss. Alright, so there we go, and here's the other part. So, pretty simple. These things are just so fragile. You have to be so careful with them. For me, it was $30 for 3 sets. Here's the, this is the secondary, that's what we're going to be removing. So you can see I've got liquid tape put on here. The coating on these to insulate the wires is pretty fragile, so I would suggest putting some kind of glue or tape, liquid tape, maybe even super glue or Gorilla Glue on yours so that you don't scratch them or anything. So that's another learning curve, and then you can see I've got my copper foil tape, and the one end of the secondary, the final end, is soldered to the copper tape. This is to help with insulating EMI and RFI emitting for the coil when the field collapses. We'll just take an X-Acto knife to cut it. Rip it all off and expose the juicy innards. Alright, we'll have to get rid of this liquid tape. It's pretty rubbery, so it peels off easily. Alright, and then it's just unwinding it. So I've taken it all from this spool onto this one. So it's a lot of copper wire, or magnetic wire. So now I gotta put 30 gauge on, and it's gonna be a ton of 30 gauge. But hopefully it'll give me my higher voltage and current output I'm really hoping for. So I've finished building my really jury rig setup. So I used a paint brush thing or whatever, took it apart, and I'm using a, you can tell I didn't have much wood kicking around. So anyways, a paint stirring stick, and I clamp it to put a little bit of resistance on the spool. I'll need to, and then I use this clamp to increase the tension by just pressing on either side, making it a bit harder for this to move. So pretty simple, and then there's it's just secured to the table using a C-clamp. I don't know. Alright, and then the drill. I just have a drill, and I took a screw and another piece of paint stirring stick, drilled a hole in it, then put the screw through it so it's nice and tight. And I painted this in the primary coil in liquid tape, just to see what would happen, yeah, out of interest. That's right. So it doesn't matter which way you wind the coil if you understand how this stuff works. And as you can see, I am really not trying to be perfect. The reason for this is I don't believe there is a huge amount of difference, whether it's completely uniform or if it's a bit chaotic. My research with the Link Steam joule ringer kind of made me believe that. I'm gonna reach my whole spool. You know what, I'm gonna stop it there, because this is gonna be an insane amount of turns. So I've super glued the end of the 30-gauge wire so it's secured in place and I don't have to worry about tension or anything. So this is my copper foil tape. There's a bit of it I bought off eBay. So the way I measured it is, just, you don't even need to worry. You're just like, okay, that's about it, good enough. And then you cut it to the right diameter of here. So, and then I'll just cut that all the length down. So I just cut it with scissors after marking both ends and then folding it to give myself a general line. It's the fastest way to do it. You really don't have to turn this into rocket science. And then I'll just peel off it, the sticky part, and then just wrap it. Here's the end of the 30-gauge wire, and we just have to solder it. I'll strip a bit of the coating off and solder it to the copper foil tape. So that'll be a little difficult. I'm just gonna take my cutting tools, these things here, and just scrape lightly and then apply this stuff. It's pretty intense flux. 30-gauge wire is so picky. You gotta be so careful with this stuff. And if we mess this up, we'll just bring it back a turn. So it's not the end of the world if you, by accident cut it in half, but just be very meticulous with this stage. If you're using 22-gauge wire, don't worry about it. 22-gauge wire, it's pretty thick. It can handle a lot. After scraping it, all I had to do was get some solder onto my soldering iron, and yeah, you can see that. So I just dabbed a lot of flux around, and then I just touch it together, and as you can see, it's nicely placed itself there, and that's pretty much it. Alright, so now it's just putting the primaries and secondaries in, and if it doesn't work, then you just flip primaries, you flip those two wires or the secondaries. It's working, and it's at the same or less brightness as before, and it's got this weird problem with it. Oh yeah, look at this, that's hilarious. I made a strobe light. Oh, you can't see it. Shit. That'd be pretty awesome if I could. Oh yeah. You see that? That is such a... Oh, then it goes higher. Alright, well anyway, so my rewinding of it worked, and did something a little bit weirder. I'm gonna have to experiment with different voltages now, because it's a whole new design, and I'm probably gonna rebuild the entire circuit as well. Oh, that's weird. Why are you working on this? This is max brightness. I think the resistor blew. Alright. Well, I don't see how, but oh well. It looks really bright on camera, but it's not. We're at the highest, which is 100,000, so times 100 lux. And let's see. So it's at 15, 16, 25. So right against it, it's at 30. 30 lux. Holy, that's pretty low. Before I was at 200. The 60 watt light bulb is like 2,000 in comparison to 30. That's full brightness of these lights with conventional. So I'll just make a whole different video on testing out what we've just built and the modification we made. We may have to go with a whole new circuit, to be honest, which is unfortunate, but that's okay. Not a big deal. Maybe if I put them all in series, they'll work better. So when I get more of these in next week, I can test that. Who knows? But anyways, like, favorite, comment, let me know what you think, and have a great night.